Hello guys, welcome back to another video. Today we're going to go ahead and learn about inverse trig applications and some review of actual just trig applications. So I want you to go ahead and pause the video and find a trig function that we can use to go ahead and find the length of the value of x. So go ahead and pause the video. Okay, so even though it is true, we can go ahead and find the length of this um, right triangle by doing the Pythagorean theorem, saying 5 squared plus 20 squared equals x squared. We can totally do that, but what I want you to know is that we will only be using trig functions. So in this scenario, you can go ahead and pick an angle, and fun fact, you can pick whichever angle you want. So let's say we pick 60 degrees. This right here will be my adjacent side, this will be my opposite. Given that I want to find x, I need to be aware that I must be using the hypotenuse. So if I'm going to use 60, I have the option of saying sine of 60 degrees, sine of 60 degrees is equal to my 20, my opposite, over my hypotenuse. Or I can say cosine of 60 is equal to 5, my adjacent, over my x, my hypotenuse. So that is not the only two solutions, guys. We could actually do with, we can actually use 30 degrees, do the same thing, sine of 30, cosine of 30. And I even had some students wanting to use 90 uh, as well. Okay, so what I want you to know is that that's what we're going to be going. Well, that's what we're going to be doing. We will either be deciding, hey, let's find the length, or hey, let's find the angle that is missing. Okay, looking at at a glance, we can see that I am still accepting the quizzes. So if you have not done so, please reach out to me. Um, and I will have the review posted by Wednesday in class, and we'll review all of Thursday and take the exam on Friday. Keep in mind, today is my first power hour, so for the students that need additional time turning in stuff in or office hours, please reach out to me. Okay, so today we'll be finding theta, we'll be finding lengths using trig functions. Okay, so the power hour schedule, so today it is for physics and pre-cal. Okay, but your rest of your teachers will be online for these office hours as well. All right, so what I want you to do first is think about what is an angle of elevation, what is an angle of depression. Okay, so pause the video, give it a try, write in your own words. So hopefully you're able to see that, hey, if I have the horizontal, the horizon, right, the ground or something, the horizon, and if I look up, right, if I look up, this is the angle of elevation. If I look down, this is the angle of depression. Okay, now what I like to tell students, because there is something that happens that is pretty unique. Let's say these are parallel lines, right, in the ground, and I guess in the some sort of ceiling, and this right here, the angle that is formed right here is the angle of depression, and this right here is the angle of elevation. These two thetas, hopefully you remember your geometry, but these two thetas right here are opposite interior angles, meaning they are the same. So fun fact, especially when you are doing your applications, there's always try to notice that, oh snap, they want the angle of depression, but I only have the elevation. Well, actually, it is the same thing, right? Assuming they follow that same, they're in within the rectangle looking deal, like parallel on the top and parallel in the bottom. You should have opposite interiors. Okay, the next thing that I want you to know is the visual of this. So like angle of depression, the guy is looking down to the boat, and angle of elevation, you're looking up to the ceiling or something. Okay. Fun fact, Desmos offers this nice calculator both for the web and for your apps. So give it a try, download it. It's pretty good. I want you to really reflect on this slide and think about like, hey, am I ready for a notebook check? So some of us are like, yeah, my notebook is exceptional. It's what Pacina should be using, or one, one and two being like, oh snap, we're supposed to have a notebook in this class, but yeah, okay, awesome. So let's continue and let's start with our first question. So let me go ahead and hide everything so we have more space. And this right here, go ahead and sketch this out. Okay. So we have here that there is a ladder, and the maximum angle in this 110 feet ladder is 72 degrees. We want to find what is the max height. So what I'm going to go ahead and do is I'm going to go ahead and draw some scenario. So I guess like a building or something. And I have the firefighters right here trying to find that the length right here, sorry, not this one, the length of the ladder, I'll try the ladder in purple, length of the ladder is 110 feet, right? 110 feet. So this is my attempt at drawing a ladder. That is 110 feet. The angle that is created, I'm sorry, the maximum angle we can do, so assuming the black is ground, the maximum angle we can do is 72 degrees. So with the 110-foot ladder and the 72 degrees, we want to find out what is the max height that I can go ahead and put this ladder up against, right? So from here, I want you to really reflect. I have 110 feet, I have the value of x, and I have 72 degrees. So if this right here is my central angle, this right here is my adjacent side, this right here is my opposite side, and this right here is my hypotenuse. So I have the theta, I have the opposite, and I have the hypotenuse. Okay, so according to this, the only one that meets this criterion of opposite and hypotenuse should be which trig function? Sine, cosine, or tangent? Hopefully you said that saw, right? Which is sine, is opposite over the hypotenuse. So in this scenario, I have sine of 72 degrees is equal to my opposite length, which is my unknown, which is x, over my hypotenuse, which is 110 feet. So from here, all I have to do is solve for my x, so multiplying by 110 on both sides. I get 110 sine of 72 degrees. Keep in mind, guys, your calculator should be in degrees. This should give me about, sorry, I wrote my answer here somewhere, 104.62 feet for my solution. So that is the highest I can go. Okay. Now, adding to this question, guys, we can actually do other additional things. So let's say they wanted this angle beta, and we only know this angle right here, the length of 104 and the hypotenuse. So if I wanted to find beta, I would have to go ahead and set up the proportion, but now this is no longer my opposite if we're talking about beta. For beta, this would be my adjacent and my hypotenuse. So we would say cosine of beta is equal to my how do you call it? My adjacent 104.62 divided by my 110. Okay. From here we can do arc cosine of both sides, right? To get rid of cosine, the only way to get rid of cosine is to do the inverse. So cosine inverse of my cosine is going to be equal to the arc cosine. What you do on one side, you must do on the other. So cosine inverse of 104.62 over 110. So when you have cosine and its inverse function, remember there's an identity, they're inverses. So therefore B is equal to the arc cosine of the inverse of 104.62 divided by 110. Okay, and I should have that solution here. If not, let me go ahead and find it. So if we go ahead and put this in our calculator to find the angle of beta, this one right here, we can see that our beta is going to be 17.99. We can argue that that is 18 degrees. And if we go ahead and check this, if this is B, 90 degrees right here, we can see that this will go ahead and give us our 180. 72 plus 18 plus 90 does give us 180, so we can see that. So I'm not always saying that, hey, you have to do the arc cosine for this. We could have easily gotten 180, subtract 90, subtract 72, and find the 18 degrees without a problem. I'm just letting you know that, hey, this is the inverse trig, and this is how we can use it as well. Let's go ahead and go to another example. So go ahead and give this one a try. Now for this one, I went ahead and gave us this sketch so we won't get messed up with just starting, okay? So go ahead and fill in this sketch. I'm sorry we cannot see the green on here, but go ahead and fill in the sketch. So we have that a point, right? A point, so we're gonna go assume that it's this one. Ideally, you would draw yours any way you want, but I like to leave them in quadrant 1. So point is 200 degrees from the base. So here's the base, right? And the angle of elevation from the bottom of the smokestack is to the bottom of the smokestack is 35 degrees, okay? So this right here, this little triangle right here, to the bottom of that smokestack. So if we're not familiar with that, it's pretty much back in the day, the factories used to burn coal for their energy, and they would need to get rid of that. So they would make these giant chimneys so it wouldn't affect, I guess, the cities that they were in, right? So from the ground all the way to the bottom of that smokestack is 35 degrees, okay? And the distance from the point to the base of the building is 200 feet, okay? The next thing that I want you to know is that the entire building, so if you want the angle to the entire building, so the building itself and the chimney, the smokestack, it's going to be a different angle, okay? It is going to be included with our 35 degrees, right? So let me go ahead and outline this right here so you can see that both triangles are here. So we have something like this, right? Okay, so that entire angle from the ground all the way to the top of the chimney is 50 degrees. Okay, so what we want to go ahead and do is we want to find the length of this chimney, which we can call the missing side is X. The base of the building, I have no clue what it is, but I'm going to call that Y. And the only way you can find out what this is if we consider the entire length of this right here, this entire building and smokestack. So I'll call that Z. Okay. So ideally, what we want to do is we want to get the entire building, right, with the smokestack. So we can draw the building with the chimney, right? Right. And then I'm going to subtract the length of the building. So if I get the entire building, I subtract the bottom base, right? I am left with just the chimney, ideally. Something like that. Okay. So we're going to get the length Z minus the length Y, and I'm all going to be left with the length X. So how the heck do we do that? So it looks simple, but it looks a little tedious when we start. So let's consider what we know. We know that these right here are my thetas, right? These right here are my thetas. And in these thetas, I am giving this side right here, and I'm going to call this my adjacent side, and these right here will be my opposite. All of these right here, the X, the Z, the Y's are my opposite sides. So I know my thetas, I know my adjacent is 200 degrees, and I know my opposites are the length X, Y, and Z. So according to this, the only proportion I know that I can do is tangent. So I'm going to go ahead and do tangent, okay? Which is my opposite, I'm sorry, yeah, which is my opposite over my adjacent. So according to this, I'm going to go ahead and look and see, okay, I'm going to go ahead and find these lengths first. So I know that the entire triangle is with proportion to the length z as my opposite, and the interior angle will be 50. So 50 degrees is equal, I'm sorry, tangent of 50 degrees is equal to my opposite, which is my entire building with the chimney, divided by the 200 feet. So by doing so, I'm going to go ahead and multiply 200 times tangent of 50 degrees is equal to z. And if I go ahead and check this in my calculator with my handy dandy notes, I have that this length is 238 with 35.35 feet. Okay, and that is my length z. Now I can do the same thing by finding my length y. So tangent of, wait, hold a minute, we have a different angle. We have that this angle itself is going to be only for the building, only for the bottom, right? No chimney, so only y, and y is projected from the angle 35. So my length opposite is y divided by 200, and we have 200 times tangent of 35 is equal to y. Okay, from here, we can go ahead and put this in our calculator, and I get to see that my solution for this will be 140 with 0.4. So I have these lengths right here, and I'll draw it in black. My length z, my entire building and chimney, is 238.35. And my length y is 140.04. So my question to you is, I know the entire building, I know the entire building and the chimney, and then I know the length of the building itself. What should I do to find only x? So as we mentioned before, we're going to go ahead and find z, which is the entire length, which is 238.35, minus my length y of just the building, which is 140.04, and the difference will give me just x, the chimney. So in this case, we have that the length is 98.31 feet is the smokestack. This right here is your solution. 98.31. Awesome. What we're going to go ahead and do next is I'm going to go ahead and help you with independent practice 1. So go ahead and take a couple seconds to give this a shot. So go ahead and sketch this scenario. Okay, so we have this swimming pool, and we're going to go ahead and look at it from the side. So I didn't add how wide it was, since that tends to confuse my students, but we have this chimney, right? So hopefully it didn't mess you up too bad. So we have this chimney. It is 20 meters in length. Now, as you've seen a chimney before, or maybe you've seen a movie, I'm sorry, not a chimney, a pool before, you notice that like it starts getting deeper as you go in. So ideally, they usually start with it being at a certain distance, a certain depth. So in this case, they told that it was 2 meters for the initial site. Then in the terminal side is a total of 5 meters. So 5 meters. Okay. So the 2 meters are all the way across. But this is what tends to confuse my students. The 5 meters, guys, is talking about everything itself. So this right here is 2. So therefore, the bottom of this will not be 5. It will actually be 3, making it a total, right? Making it a total, sorry, that's not my eraser. Making it a total of 5. So that's where that comes from. Okay. So this right here messed up my students a little bit, but hopefully it doesn't mess you guys up. This right here is 5. Okay. So we want to find the angle of depression. So hopefully you can see that this is your right triangle right here. And we can go ahead and get this length, which is the same thing as saying this right here. So we can go ahead and see that we have the following. We have a theta, right? We have the theta, that's what we want. we have a length opposite, and we have this length right here, which is our adjacent. So according to this, if we have the opposite, sorry, that's horrible handwriting, opposite, so that's worse. We have the opposite, we have the adjacent. This right here is referring to our tangent. So our tangent over theta is equal to my opposite side, which is 3, right? Because opposite side of this part right here, not the 2. And then we have our adjacent, which is 20. So this right here, we have tangent of theta is equal to 3 over 20. Keep in mind, we want theta itself. So the only way to find theta is if we do the inverse tangent of both sides. So the inverse tangent of 3/20ths. So we have theta, right? Because tangent of an inverse tangent, I'm sorry, inverse tangent of tangent is just the inside, which is theta. It's equal to tangent inverse of 3 over 20. And our theta should give us approximately 8.5 degrees as our angle of depression. Okay, awesome. Hopefully that helps, guys. I do have one more question, but I will go ahead and leave it as homework. Please reach out to me in my office hours if you do need additional support, or send me a chat message and I'll help you out as best that I can. As always, guys, it was a pleasure and thank you. See you guys on the next video.